Hey, what's up, Algebra 1? Mr. Catlin here, helping you out with your math homework, lesson 1 here in Unit 7. And we're looking at this frame situation that we did in class today. And I know it's kind of a little bit rushed toward the end of class about understanding the adding the two unknown border widths, but I'm going to try to explain it a little bit better here in this example. So maybe you can grab it from this if you're watching it at home. I hope so anyway. All right, so let's say that this green box here is the photograph that you're framing, okay? And I'm going to put a pink rectangle around it to create a border of the frame. There we go. All right, so there's my picture with the picture frame border around it in pink. And in this situation, we are told what the length of the picture is and the width of the picture. So we would know like the green parts. But what we didn't know in the situation was how thick the frame was. So for example, we would know that, from here to here in this scenario, the longer side appears to be 10. So 10 inches. And the shorter side 10 looks like it's an 8 by 10. It's an 8 by 10 photograph. Most of the time, those are probably in portrait form, but we'll roll with 8 by 10 going landscape style. And what we don't know in this situation are a couple of different things. And I'm going to draw a line here to kind of help us see this. So I know that from here all the way across is the length of everything inside, right? And I know that it's at least 10. It's at least 10, but I also know that I have this extra border that's been added to each side. So I know this part is 10, but I don't know how wide I made the border thickness. So those are represented by two unknowns. This is where they get this expression right here. Okay. It's 10 plus 2x's long. And then this direction will go this way, and I'll freehand it because I don't want to switch back. Okay. This one we know from there to there is 8 plus the 2 x's of the width of the frame, hence this part. So by multiplying these two things, you're essentially multiplying the width times the length. So you're finding, when you do this width times length, what are the length and width of the picture without the frame? Length and the width of the picture without the frame, well, we know that it's 8 by 10 because, that's where those two numbers came from. It's an 8 by 10 photograph. What would a solution to this equation? So when we multiply those two things together, width times length of everything is the area of picture with frame, right? So if they set up this equation where 100 has replaced y as the output of the function, then they're saying that everything has an area of 100 square inches and width times length is equal to that. Okay, so we could say that the area of picture with frame included, with the frame included is 100 inches squared. And what we talked about at the end of class is what we're trying to learn this unit is solving for x. Because if we can solve something like for x, we know that everything included is 100 square inches, and we just want to know what x is, then we can figure out how wide we need to make that frame to use up all the area that we have. And so that's what we're going toward here. We're interpreting the solution now, but we're going to be finding that solution within this unit. All right, so that's all you really need there. I hope that was helpful to help get you to understand lesson 1 a little bit better. It's kind of a weird introductory to quadratics and solving equations for them, but hopefully this was helpful. See you guys.